Good morning, everyone.
Good morning.
Videos on, everyone. I just have to announce something. So please, video on. Anyone has started doing TMA? Anyone has started? No?
એ પરમ દિવસે મેં કહેતા ફૈયાજ ના કરતી ની કાઢી હતી અમન ની
Khalid,
મને તો BMW
Khalid, video on and mute yourself, please. Saklen, Mudabbir. Saklen, I can see two windows. You are there here also, and there also one more, your profile picture is there. Everyone get ready. Okay, fine. Fine, Saklen. Okay, video on, please. It's already 10:01. Okay, so if you go through on the website about TMA's questions I have already discussed. Okay, for science and maths both, if you want, I'll send it on Google Classroom also, the link, and I'll create one assignment on Google Classroom. Okay, you have to solve it and submit it on by 15th of December. Okay, everyone please write down this in your notebook, that you have to submit the TMAs on by 15th December. If before that, if you want to submit, it is fine. So that I can check it also and keep it proper, right, neatly, because you are going to get marks for it. Okay, and as I have told you, if you are making this rough, most probably you have to make another copy, because there might be some mistakes and I'll correct whatever things are there. So submit it, and then you have, because the presentation, you will have marks on presentation also on the final copy. Yes, Khalid, Faz, Farhana, Yusuf, Mudabbir, keep your videos on, everyone, please. I'm talking something important for you. Yusuf, are you there in the class? And those who are not
Yes,
there,
ma'am,
please let them know what I have told you, because this is important. This is for your board marks I'm talking. So about TMAs, I was telling you, complete your TMA, science and maths both, submit it on Google Classroom by 15th December. Okay, 15th December is the last day, so that I get some time to check it, and by the end of December, okay, fine, Mawsam. So by the end of December, you get back your no, what do you say, the corrected copies, or I'll let you know what mistake you have done so that you can correct it. Okay, if you have any doubt, because we have classes going on, any class you can ask me the doubt, even you can ask me through message also. But suppose if message I'm not able to check or reply, but I'm there in the class, you can ask me in the class also. Okay, mostly maths ke science, so we have discussed physics and chemistry. Biology, if you face any difficulty, you can ask Daud sir. Okay, and physics, chemistry, if you have any difficulty, you can ask me. Maths also, I have discussed some of the questions. Rest of the questions, if you're not able to, you can ask me. Okay, so the last date of submission of TMA on Google Classroom is 15th of December. This is not the final one. this I would be checking, and if any mistake, anything is there to correct, you will correct it and make a proper fair copy. Okay, so now also you make a proper copy only, so that and how, you know, it's like a project, so it should be beautifully done also, like you do your project works in school now, that way it should be there. Okay, so is it clear about TMA? 15th December. See, I can create assignment any day, but I have told you orally that it is 15th December. I will put it on Google Classroom. You might not see because we'll be having assignments every day. I'll be submitting I will be posting assignments over there. You might miss it, but remember it is on 15th December. Even if you don't get it on Google Classroom, I'll create a, do you want the question paper of TMA? Or everyone has it now? I'll just write that complete TMA by 15 December. Is that fine? You have now question paper of TMAs, everyone knows where it is, so you can solve it. Okay. Also, there are some instructions how to do how to solve this TMA, fair TMA, how to solve the answers and do it. The instructions are there on the website only, so you can go through that also. Okay. Just a moment, give me a. Okay, this was about TMA. Then, as you know, you questions of TMA you want to share?
Yes, ma'am.
Okay. Okay, fine. I'll send it to you. Remind me if you don't get it. It is there online. Sometime I might also. Yes. Yes, Faz, that is the fair one that you have to solve. Yes, instructions you have read, Faz. It is one side plain, one side rule. That type of paper you have to solve it. On that type of paper you have to solve. Okay, I'll just find out the instruction and that also I'll send it to you. That is for the fair one. This one I'm just asking, like for me to correct. That will be the final one. Okay, one side rule, put a margin, proper topic, proper question. That way you have to solve the final which you are going to submit to the board. Okay. Okay, I'll create one assignment on Google Classroom and I'll put question paper and I'll see if I get the instructions also. I'll put it, I will put it there. Okay. Okay, so this was about TMA. The second one is in like all of you know that it is mentioned in your planner that there will be exam in December end. Okay, so for now for your class there won't be any exam, but I can take any simple test also. Class test I can take any day. Okay, so there won't be any exam. We'll be completing the syllabus in normal classes only, but I might take class test on my subject like I took earlier. Okay, is it clear? Fine.
Yes, ma'am.
So keep on preparing it because January you will have exam then. So because we'll be having full syllabus by then. So prepare for it. Please do the terminal exercise questions, the exercise question, and then the worksheet question, which is given on NIOS site. Okay. And after that, even after that also, you can do some extra questions for maths. I'm talking for maths, you can take, I have given you reference books also. It is there online, extra questions you will get. So more you practice, more you are able to solve it easily and you will take less time. If you practice more, you will take less time. And 2.5 hours you have to complete 85 marks ka paper. Okay. So practice is important. Practice is required. Okay. So let us start with our class today. Please keep your videos on now. Let us start with our class now. We'll have a class discussion on the next topic. What is the chapter that we are going to do? Ahmad, Khalid, Faz, Uzair. What is the next topic that we are going to do today? I told you in the last class.
Ma'am, magnets. Magnets.
Correct. So magnetic effects of current we are going to do, that is related to magnet. Okay. So what previous information do you have about magnets? You have read magnets in earlier classes, I think, right? So what do you know about magnets? What comes to your mind?
Attraction.
Attraction. Okay, magnet attracts everything.
No, only iron and nickel.
Yes, so only magnetic things, right? Magnetic material only, like iron. So metallic things, it will attract. Okay. Okay, so what type of magnet? Do you have magnets at home? Anyone has magnet at home? Khalid, you have? You have magnet? What type of, can you bring a magnet over here?
Ma'am, like I don't know where it is, but I
Okay,
have.
fine. So next class, you please find it out. Those who have got magnet, please find it out so that we can have a small activity in the class. Okay. Anyone else has got magnet? Any type of magnet? 2 magnet or 3 magnet, if you get, just bring it for the next class. Okay. So magnets, you know that it only one property, you know, magnet attracts or repel things, right? Okay. Now see, magnet or any charge, these are two different things. Charge means electrostatics. Okay. Now, if there is a charge, there is something created around a charge, right? So that it can attract or repel a opposite charge, right? Or like charge, right? This property is there for a charge. If two charges, two like charges are there, like negative and negative, they will attract or repel. Two negative charges are there. They will repel. Why? Because they are negative, and one positive, they are like charges. If one positive and one negative is there, then what will happen?
And they'll attract.
They'll attract because they are opposite charges. Okay. Now similar thing happens in magnetism also, but like, and here we have poles, not charges. Okay. Now any magnet, if you suspend freely, you know what is suspended freely? You know what is suspended freely? Means if you tie a magnet in between and you hang it like this. Okay. So if any magnet is suspended freely, it aligns itself in a particular direction. Okay. It will always be, and if you shift it in particular, if you twist it in a particular direction, again, it comes back to the original place. Okay. So if any magnet, it is suspended freely, it aligns itself in north-south directions. These are the properties of a magnet. Okay. So we'll study now some properties of magnet, how it behaves and what is there around it. Means if you have a magnet, there is something created around it that is called as magnetic field, and that we are going to study in this class today. Okay. So let us start with our chapter today. Okay, magnet and its property. Now types of magnet, if you see, types of magnets are bar magnet, cylindrical magnet, rectangular magnet, horseshoe magnet, circular magnet. Mostly we use, in doing experiments, we use horseshoe magnet or bar magnet. Okay, most of the time in activities also we use these type of magnets only. You can see over here horseshoe magnet. It is like this. Okay, horseshoe in the shape of horseshoe. These are bar magnets. Okay, these are bar in the shape of bar. These are circular magnets. This is cylindrical magnet, rectangular magnets. Okay, so now horseshoe magnet you have seen, bar magnet you have seen. And these are used in various devices like doorbell. You can see over here, radio, motor, headphones, tape recorder. So in various things, these are used according to the use. Okay. Now this I was telling you, when you hang any magnet freely, this is suspended freely, tie it over here. You see that this magnet aligns itself in north and south direction. Okay. Particular direction में south आएगा, particular direction में north आएगा, and it is actually geographical north south direction में it will hang. Okay, geographical north south means earth का north south. So whichever direction earth का north is there, in that direction magnet's north pole will align itself, and whichever direction earth south pole is there, that direction magnet aligns its south pole also. Okay. So this is a property of bar magnet. When it is suspended freely, it aligns itself in north-south direction. Okay, why it happens, I'll explain you in the next class. Okay, later on. Okay, so this aligns itself in north-south direction. Now, if you take iron filings, you know what are iron filings? Iron can very small pieces of iron. Okay, so if you place iron filings near the bar magnet, you will see that most of the iron filings get cling to, because iron is what? Iron is a magnetic material. So most of the iron filings get attracted towards the ends of the magnet. Okay, and very few will get attracted towards these two sides. Okay, so this shows that there is maximum force of attraction at the end of the bar magnet. That means at the poles. Okay, so that means magnetic field strength is maximum at the poles, means at north and south ends. These are called as poles. Okay, these are the poles of magnets. Okay, now if you place two bar magnets in this way, like south and then north, you will see that these two, if you have two bar magnets, you can do it at home also. You will see that these two will attract each other and they will stick towards each other, because force of attraction is there, because these are unlike poles. Okay, now if you do this north and north, even at home also you can try this. You push these two bar magnets towards each other. What will happen? You will not be able to stick these two ends together. Why? Because these are like poles. They will never attract each other. They will always repel each other. So you will feel that you're trying to put these like poles together, but they will not come together, and you will feel a repulsive force in your hand. Okay, so that is why I was asking, if you have two magnets, you can try this at home. Any magnet you can use, not only bar magnet, any magnet you can use. Okay, so you can see over there that two like poles will never come together. Okay, because these are like poles and they will repel each other. So these are the properties that we are doing. These are the activities on basis of which we define the properties of magnets. Okay, then the fourth one. If you take an iron ball pin near a bar magnet and leave it for some time, after some time, when you take out this ball pin and remove the magnet, okay, you will see that this ball pin behaves like a magnet, and it will start attracting other magnetic materials. Okay, that means what happened? This has attained magnetism. It behaves like a magnet. Why? Because it was left for some time with the magnet. Okay, so it gained magnetic properties and it behaves like a magnet after some time. Okay, understood this? Okay, now if you cut a bar magnet into number of pieces, suppose ye bar magnet ko cut into two pieces, you will see that this end will be north, this end will be south, and this end will become south, and this end will become north. Okay, again, if you cut these into further two pieces, you will see that this north, this south, this is north, this is south. So this way, the north and south pole align itself. Okay, so based on these activity, the properties were defined, which is very important. What are the properties? That properties of magnet, it is that attracts iron towards itself. Second, when it is freely suspended, magnet always rests at the north-south direction. Always it will attain a north-south direction. Even you rotate it, after some time when it comes to rest, it will attain itself in north and south direction. Like poles repel while unlike poles attract. If iron pieces are brought near a strong magnet, they also start behaving as a magnet. Okay, the poles of the magnet cannot be separated. So even if you cut it into number of pieces, you will have the pole. Why? What is the reason? Because magnetic monopoles do not exist. You can write this point over here. This is a very important point. Okay, magnetic monopoles do not exist. That means even if you cut it, you will have its pair. Okay, north hai to idhar south ho jayega. तो it is very important. Like in charge के cases में क्या होता है, you have mono charge, like single point charge is there, plus q or minus q, but you will never have a north pole alone. You will not have a north pole or a south pole alone. You will always have a north and south pole together. So magnetic dipoles exist, monopoles do not exist. Okay, whereas charges may you have single charges. There is existence of single charges. Okay, now in case of electric field, we studied that if you place a plus q charge and a minus q charge or any other charge, there exists a force between them. Okay, there exists an attractive force between them, and that force ka formula we read as Coulomb's law. Okay, why this force is there? Because there is a field created around it. ये दोनों का एक दूसरे के this creates its own electric field, and this also creates its own electric field, and because of which they experience a force. Okay, so magnet is there, magnet also creates its own field. Now what type of field is created around it, which direction you will see, what is the field, what type of field is created, that we'll study seeing one activity. Okay, because something is there, that is why when you bring an iron piece over here, it gets attracted. Okay, that means it is pulling, this magnet is pulling this iron piece towards itself. Why? That means there is a magnetic force present over here, because of which this is pulling it towards itself. Or if it is repelling something, that means there is a repulsive force over here. Okay, so what type of force and how this force come, let us see one activity. Okay, I'll show one video. Mudabbir, please pause the recording. I'll show one video and then we'll understand. What you saw over here is, this is a bar magnet. This is north, this is south. Okay, you have a north and south pole in bar magnet. The field is such that, and you have seen that maximum amount of magnetic strength is at the end. So that is why the field is like this. Means field lines, these are called as field lines. Inside you have just straight lines, means uniform magnetic field is there. So inside you have parallel straight lines, means the magnetic field inside the bar magnet is uniform, and the field line is, it should always enter from south and leave from north. So field lines are like this. You saw this type of shape when the iron filings arranged themselves in this shape. Okay, arrows are important. Now how arrows are important, this is my rough diagram. Actually it is like this. So you can see over here, okay, you cannot have intersecting lines. This goes on, मतलब यहाँ पे too many lines are there because the strength यहाँ पे ऐसे ऐसे होता रहता है. Now the arrows are there. Yeah, actually this is bigger circle, so that is why it is showing like this. ऐसे बनता है. So the line's arrow is entering from south. All the arrows should be like this. So magnetic field direction is from south to north inside the magnet, and from north to south outside the magnet. If you see, the arrows are going like this, and these are continuous loops. There is no break. Okay, so these are the magnetic fields. This is a bar magnet. arrows are coming out. So always remember the magnetic field lines or direction of magnetic field is always coming out from North Pole and entering into the South Pole. If you see the direction inside the magnet it is from south to north. Sometimes direction is asked. What is the direction of magnetic field in a magnet? So inside the magnet, it is from south to north. So it is like this. Magnetic field is uniform inside a magnet. So all the arrows will be entering into the South Pole, exiting outside the North Pole. So this is an important characteristic of a bar magnet. So this, how we came to know about this, when you sprinkle iron filings on the magnet, okay, you saw that the iron filings arrange themselves in this pattern, okay. So these are called as magnetic field lines. And what does it depict? Any place, if you draw a tangent, it gives you the direction of magnetic field at that place. Suppose I want to find out the direction of magnetic field at this point. I'll draw a tangent. You know what is a tangent? Now we have read circles and tangent. So a line which touches that curve at one point is tangent. So if I draw a tangent like this, so this is the direction, and arrow is towards this direction. So arrow will be here. So at this point, magnetic field is like this. Okay. These magnetic field, wherever the lines are dense, there the strength of magnetic field is more. Wherever the lines are far away, there the strength is of the magnetic field is less. Okay. So these are the characteristics of magnetic field lines. Inside, if the lines are parallel, that means magnetic field is uniform. Okay. So field is uniform inside the bar magnet. Uniform means constant. Okay. Strength is constant everywhere. Uniform magnetic field. Okay, so inside a bar magnet, field is uniform. At the ends of the bar magnet, field is very strong. Okay, field is very strong at the poles. So these are the important points to remember. Let me see what is written in your book. Field lines are. Okay. Also, one more important property of these field lines is that field lines do not intersect. Now, why they do not intersect? Reasoning hai nahi, but you understand, then only you will be able to remember it. Why field lines? Field lines do not intersect. Why they do not intersect? Because see, suppose for example, if two lines intersect at this point, ek aise ja raha hai, ek aise ja raha hai. So what will be tangent? There will be two tangent, one tangent in this direction, one tangent in this direction. So at the same place, you cannot have two directions of magnetic field. There can be only one direction of magnetic field. So that is why two magnetic lines can never intersect. This is a very important property. Higher classes may reason is asked. Okay. So why? Because at two magnetic lines can never intersect, because there cannot be two direction of magnetic field at the same point. Okay. So that is an important point. Okay. So let us see what is there in your textbook, the properties. ओके सो मैग्नेटिक फील्ड लाइंस या मैग्नेटिक लाइंस ऑफ फोर्स सेम थिंग है, ठीक है. Magnetic field lines you can say, or magnetic lines of force you can say. So magnetic lines of force always start from north pole and end at the south pole of the magnet. Okay, actually end नहीं होता है, continuous रहता है, but for younger classes they have told starts and end. You can see over here they have also shown parallel lines inside. So start from north pole means comes out of the magnet from the north pole and enters from the south pole. Second line, these line of force never intersect each other. I have already told you, near the pole magnetic lines are very close to each other. This also I have showed because the strength is maximum. So that is why the closeness of the magnetic field lines shows you the strength of magnetic field. The lines are far away, that means they are the strength is lesser as compared to this place. Okay, so near the poles of this is important, huh? Properties of magnetic field lines are asked in questions. All points are important. So near the poles of magnetic lines are very near to each other, which shows that magnetic field at the poles is stronger as compared to other parts. Okay, इन्होंने 3 ही point दिया है, so you can remember 3 points. These are the 3 most important points. Okay, one more thing is there. Now, why I told you that when a magnet is suspended freely, it aligns itself in magnetic in north-south direction. Okay, Earth ka bhi, this is Earth ka north towards here and Earth ka south. ऐसा होता है. So why it happens? Because Earth, you know, core of Earth is magnetic. Okay, so Earth behaves like a giant magnet whose magnetic, this is Earth, this is अंदर जो बनाया, this is Earth as a magnet. Okay, so Earth behaves like a giant magnet whose north pole is towards the geographic south and whose south pole is towards the geographic north. So that is why Earth magnet, it will self towards unlike poles. So Earth ka as a magnet, south pole is towards this side. They will not overlap. Huh? There is an angle gap, 11.3 degree. Okay? It is written over here. Our Earth itself acts as a giant magnet with south magnetic pole somewhere near the Arctic and north magnetic pole in Antarctic. Understood this? Means the geographic south hai, that is Earth as a magnet ka magnetic north. Getting it or not? Just a moment, I'll draw it once again. This is Earth. Okay, Earth is a magnet, so I am drawing it like this. Now this is Earth ka geographic north. Okay, geographic north means the north pole, and this is south pole, geographic south. Okay, but Earth behaves like a bar magnet whose magnetic north pole is towards geographic, not north pole, huh? South, ulta rehta hai. Whose magnetic south pole is like this and magnetic north pole is towards here. Okay, so this is Earth. Earth ka core is magnetic, so Earth ka magnetic south pole lies towards this. Okay, Arctic and north magnetic pole in Antarctic. Okay, so north pole Antarctic is south pole में होता है ना, south में Antarctic is there, everyone knows that ना. So magnetic north pole is towards the geographic south of Earth and magnetic south pole is towards geographic north pole of Earth. Okay, so that is why when you suspend any magnet, तो उसका magnetic north pole is towards geographic north. Understood? Getting it or not? If I suspend a magnet over here, तो इसका unlike pole should attract ना, so that is why magnetic north pole, bar magnet का magnetic south pole aligns itself in geographic north and south. Is it clear? Yes. Or should I explain? Should I explain once again? Is it clear or not? Tell me please. Yes or no?
Ma'am, it is clear.
Clear ना everyone? See, जो geographic north south है, that is Earth का magnetic south north. That you have to remember. Okay, Earth का geographic north and south is actually Earth has a magnet का magnetic south and north. जहां पे geographic north है वहां पे as a magnet it is magnetic south. Is it clear? So that is why when you suspend a magnet, so magnet will have unlike poles together. So that is why magnetic north जो bar magnet का है which we are suspending on Earth is towards the geographic north, because basically that is Earth का magnetic south. समझ आ रहा है ना? मैग्नेटिक ज्योग्राफिक ये सब उल्टा दिमाग में क्लियर कर लो. इफ इट इज कंफ्यूजिंग टेल मी, आई विल एक्सप्लेन इट वंस अगेन. इट्स क्लियर ना? हाँ,
Yes, ma'am.
okay. So that is why when a magnet is suspended freely, it aligns itself in geographic north-south direction. Okay. So due to this, if a magnetic needle is suspended freely, so that is why compass is used, na? Because compass is what? A magnet only. So compass needle suspended freely, it rests in north and south direction. So that is why compass is used for navigation. Okay. This is an activity you can see if you have two bar magnets. If you have two bar magnets, if you are placing south and south towards each other, what you will see that they repel each other and you will feel that force. Okay, even if you try with your full effort that you tend to stick these two ends, it will never stick. Okay, it will just push itself here and there. So there is, and you will feel that there is some force is there which is not, because of which you are not able to push the two magnets together. Now same way south and south, same way here force act in these two directions. If you are bringing north and south together, you will see that a force will attract. Even if you are trying to pull them apart with your full force, you will see that they are trying to attract each other and they will stick to each other. So this is an attractive force. Okay, so this is an activity. Define magnet and list its property. It is there in the theory. Please do this in your notebook. Okay, what happened with the properties of magnet when it is broken into two pieces? We have done this. Find out the answer. Name the part of telephone where magnet is used. Find out this. Hang the bar magnet with the string. It will always rest in which direction? Which direction it rests?
North, south.
North, south. Yes. Do magnetic field exist through space? Yes or no? Find out the answer. Go through the chapter and please find out. I'm sending you this as assignment. The North Pole magnetic needle point towards Earth. Yeah. The North Pole magnetic needle point towards Earth's.
South pole.
Earth's what? North Pole only, na? Magnetic needle is any magnet suspended on Earth. Okay. So it always points towards Earth's North Pole, geographic North Pole only. What are magnetic poles? Okay, so this chapter is theoretical only, so you'll have to write these answers in your notebook. I'm sending you this as homework, so please write down this. Okay, next is Oersted experiment. I will show you this experiment. We have 5 minutes time, so I'll show you this experiment in the form of video only. He's Oersted and he demonstrated one experiment which showed how current, when it is flowing through a wire, how it produces magnetic field. Okay, so because of his experiment, he was able to say that whenever there is a current through a wire, there will be magnetic field around it. We have already read that current through a wire produces heat. Okay, so he showed through his experiment that it produces magnetism also. Okay, so let us see this experiment, because explanation se better hai. Let us see this experiment in the form of video.